The Federal Highway Administration's Mobile Asphalt Technology Center, or MATC, brings hands-on education, technology demonstrations, field pavement evaluations, and asphalt materials and mixture testing straight to transportation departments. The MATC introduces emerging asphalt technologies into practice, assisting agencies with positive change and promoting innovation within the asphalt industry. This video shows how the Indirect Tensile Asphalt Cracking Test, or IDLCT, is run in the MATC laboratory. We'll share some tips and tricks that our crew have learned about the test along the way. There is no federal requirement to use this test. This test is performed on lab-compacted asphalt mixture specimens at 25 degrees centigrade or 77 degrees Fahrenheit. The goal of the IDLCT test is to generate a parameter, also known as CT index, that determines the asphalt mixture's resistance to cracking. A minimum of 3 replicates is needed to run the IDLCT test. Determine the air voids, which typically is 7% plus or minus 0.5% air voids. Measure the thickness and diameter of the test specimens with vernier calipers. The standard test specimen should be 150 plus or minus 2 millimeters diameter by 62 plus or minus 1 millimeters thick for asphalt mixtures having a nominal maximum aggregate size of 19 millimeters or smaller, and 95 plus or minus 1 millimeters thick specimens for a nominal maximum aggregate size of 25 millimeters or larger. Condition test specimens to target test temperature for 2 hours plus or minus 10 minutes. The test should be completed within 4 minutes after removing the specimen from the environmental chamber to maintain an even temperature. While the specimens are conditioning, we set up the IDLCT loading frame and jig and log in our first sample information. Next, we calibrate the device based on the manufacturer's recommendations before starting the test. Inspect the device to ensure the load cell and LVDT arms are secure and tight. Inspect the loading frame to ensure the surfaces are clean and free of debris. Next, we input the sample information into the software, including the sample ID, diameter, height, and air void information. Run a warm-up sequence as per the manufacturer's recommendations. An important point to remember is to load the specimen and complete the test under 4 minutes after removing from the conditioning chamber. Place the specimen under the loading frame and align the specimen with the center of the loading frame. Improper sample alignment can affect the results. The machine imposes a small contact load of 0.1 plus or minus 0.02 kilonewtons in load control with a loading rate of 0.05 kilonewtons per second. Once the contact load of 0.1 kilonewtons is reached, the technician will be prompted to select the yes or no option on the software for the machine to continue loading the specimen at a rate of 50 millimeters per minute. The test stops when the load drops below 0.1 kilonewtons, or about 90% of the peak load. Record the load and vertical deformation continuously to calculate the cracking tolerance index, or CT index, using the software provided with the IDLCT. A bell-shaped curve on the load displacement graph indicates successful completion of the test and can provide for proper calculation of the CT index parameter. On a successful test, the test specimen typically fractures alongside the center line of the specimen and splits the specimen into 2 halves. The CT index is a performance indicator that can help identify crack-prone asphalt mixtures during the mix design and production phases. In general, a higher CT index value would indicate a greater cracking resistance of the asphalt mixture. To learn more about balanced mix design and other testing activities being demonstrated by the MATC, visit our website at www.fhwa.dot.gov/pavement/asphalt/MATC.